Hello students, how are you? So in the previous video of motion and time, we have studied distance time graph, how to draw the distance time graph. I hope it was clear to you. In this, and as it was the last topic, so in this video we are going to discuss the exercise of motion and time. So I want that everyone should have NCERT. But before starting the exercise, let's take a look what you have learned that is given in the NCERT at the end of the chapter. Okay, so the first point that is given is the distance moved by an object in a unit time is called its speed. Yes, definitely we studied the formula of speed. It was distance divided by time. Second, speed of the objects help us to decide which one is moving faster than the other. Yeah, you can compare the speed of two objects, then you can tell which one is moving faster than the other. As I told you in the example in the first video, that if A is moving at 45 km per hour and B is moving 60 km per hour, then which one is faster? Definitely B is moving faster. Third point is the speed of an object is the distance traveled divided by the time taken to cover that distance. We have discussed the formula also, and we have done lots of questions related to that. Its basic unit is meter per second. Okay, basic unit is meter per second. It can be converted to kilometer per hour also. We have done we have studied conversion of speed formula. Next point, periodic events are used for the measurement of time. Periodic motion of a pendulum has been used to make clocks and watches. Okay, we told you that how our ancestor used to measure time. They use periodic events that occurs in nature. Okay, next one is motion of objects can be presented in pictorial form by their distance time graphs. I told you what are graphs. Graphs are certain representation of a data in a pictured form, in a pictorial form. So this is saying motion of objects can be presented in pictorial form by their distance time graph. On one axis you have to take the distance, on other you have to take the time, and then whatever the data, whatever is given to you, you have to plot on the graph. Okay, then the next point is the distance time graph for the motion of an object moving with constant speed is a straight line. We have seen in the last video also that if it is moving with constant speed, then the graph is a straight line. Okay, means it is constant, it is constantly moving at same speed and covering same distance in a some interval of time. Okay, and we have also discussed what if the object is at rest, then the graph is a straight line also, but this time the graph is parallel to the time axis. In the first case, means for moving with a constant speed, it is a straight line, but it is in parallel. It starts from origin and goes on straight, okay, at some angle. Getting it? So these are some points that had been given in your NCERT, at the back your NCERT. I hope these all are clear, because we already have discussed these points. Okay, so I hope it is clear. So let's move to the exercise. So students, let's discuss the exercise. Take a look at question number 1. What is it saying? Classify the following as motion along a straight line, circular or oscillatory motion. You have to tell, there are certain motions given, and you have to tell which of these is a motion along a straight line, circular or oscillatory motion. Okay, so let's start. Take a look at first option, motion of your hands while running. Yeah, it will be oscillatory motion. Why it will be oscillatory motion? I told you oscillatory motion is a to and fro motion, and when you run your hand, the motion of your hand, sorry, is to and fro about a point, and it is repeating itself, so it is also periodic. Okay, so it will be oscillatory motion, motion of your hands while running. Getting it? First answer is oscillatory motion. Second, motion of a horse pulling a cart on a straight road. Yeah, it is simple, motion along a straight line. The answer of second will be motion along a straight line. Third, motion of a child in a merry-go-round. I think it is simple. In a merry-go-round, it is a circular motion. Okay. Fourth, motion of a child on a seesaw. You have to choose from either it is a motion along a straight line or circular or oscillatory. So what will be fourth? Motion of a child on a seesaw. Yes, it will be oscillatory motion. Fifth one is motion of the hammer of an electric bell. Yes, it is also oscillatory motion. Why? Because the hammer keeps on hitting the metal that is in the bell. So it is also oscillatory motion. And the last one is motion of a train on a straight bridge. And again it will be motion along a straight line. So I hope question number 1 is clear to all of you. So now let's move to the second question. So let we start. Shall we start? Sorry. Which of the following are not correct? There are certain 5 statements given and you have to choose which of them is not correct. So let's take a look at them one by one. First one is the basic unit of time is second. Is it correct? Yes, it is correct. The basic unit of time is second. Second one, every object moves with a constant speed. Is it correct? Is it correct, students? No, it is not. Some object may move with constant speed, the others may not. So this one is not correct. Second option is not correct. Getting it? First one was correct, second is not correct. Now let's take a look at third. Distance between two cities are measured in kilometers. Yes, it is also correct. Okay, because you have read the board when you are on a journey, then the distance between cities is always measured in kilometers, that how much kilometer is that city. Fourth one, the time period of a given pendulum is constant. This is also not correct. Okay, the time period of a given pendulum is constant. It is not correct. Now let's take a look of the fifth. The speed of train is expressed in meter per hour. Is it so? No, it is also not correct. So the correct will be the speed of the train is expressed in kilometer per hour. Getting it? So the question asked you which of the following are not correct. So not correct are second, fourth and fifth. Okay, we already have discussed them, so I hope it is clear to you. Getting it? So now let's move on to the next question, that is question number 3. A simple pendulum takes 32 seconds to complete 20 oscillation. What is the time period of the pendulum? I told you, students, that time period is the time taken to complete one oscillation. So how will you solve? I think we have discussed the question, but let's discuss it again. Number of oscillation is 20. Okay, you will write number of oscillations equals to 20. Total time taken will be 32 seconds. So therefore the time taken for one oscillation will be 32 divided by 20. Unitary method, as I told you. Okay, so please try to solve it. I have given you the hint. What hint? It is almost a complete solution. Okay, so the answer will come 1.6 second. Okay, we have discussed this question in the previous video, in the simple pendulum video, sorry. Okay, so shall we move on to the next question? Okay, so the next question, question number 4 is the distance between two stations is 240 kilometer. A train takes 4 hours to cover this distance. Calculate the speed of the train. So what do we have to do here? The formula of speed. We know the formula of speed is distance upon time. What is the distance here? The distance between two stations is 240 kilometer. And what is the time given here? 4 hours. And it is not saying calculate the speed in meter per second or anything else. So you have to calculate it in kilometer per hour in whatever the data is given. So the distance is 240, time taken is 4 hours. So speed is equals to distance divided by time. So 240 divided by 4, the answer will come 60 kilometer per hour. Okay. Now let's discuss the fifth question. The fifth question says the odometer of a car reads 57,321 km when the clock shows the time 8:30 am. What is the distance moved by the car if at 8:50 am the odometer reading has changed to 57,336 km? Calculate the speed of the car in km per minute during this time. Express the speed in km per hour also. Okay, now odometer, which reads the distance traveled by the car. Okay, when at start means at 8:30 am it reads 57,321 km, and at 8:50 am it is 57,336 km. So how you will calculate the distance? You will subtract these two, means the final reading minus initial reading. So you will subtract 57,336 km minus 57,321 kilometers. Okay, so the distance covered will come out to be 15 kilometers. Now how much time is taken? The clock shows the time 8:30 am and after that it is 8:50 am. So we can say that 20 minutes. The question is saying the clock shows the time 8:30 am when the reading was first taken, and when the next reading was taken it was 8:50 am. So now we have the time also, and look at the question. It is saying calculate the speed of the car in kilometer per minute during this time. So what you have to do, you have to just take the distance and you have to divide it by kilometer per minute, means distance is equals to 15 and divided by 20. Okay, 15 divided by 20, answer will come in kilometer per minute. Now it is saying express the speed in kilometer per hour also. Now you have to convert minute into hour. How you will convert minute into hour? By dividing the minute by 60. So in hours it will come out to be 20 divided by 60, 1 upon 3 hours. Okay, so the speed then in kilometer per hour, you can divide 15 divided by 1 by 3. Then the 3 will come in the numerator, it will get multiplied by 15. So it will become 15 3s are 45. The answer will come 45 kilometer per hour. Okay. See, it is simple, students. First calculate the distance covered. How will you calculate the distance? By subtracting the final reading with the initial reading. That will be the distance. Then you have the time. The clock shows 8:30 am and the second reading was taken at 8:50 am. So the time was 20 minutes. First the speed is asked in kilometer per minute. So you will divide the distance that you have calculated by 20 minutes. That is, the distance was coming 15 kilometer and you will divide it by 20 minutes. The speed will come in kilometer per minute. And when you have to convert it into kilometer per hour, I have told you that to convert minute into hour, you have to divide it by 60. Okay. So shall we move on to the next? Sixth question. The question says Salma takes 15 minutes from her house to reach her school on a bicycle. If the bicycle has a speed of 2 meters per second, calculate the distance between her house and the school. We have done these questions when we were discussing the topic speed. We have done this kind of questions. So I think it will be done by you. Okay, but the problem here is that speed is given in meter per second and the time is given in minutes. So now I hope you are clear what you have to do. Yes, you have to convert first the time into seconds. How will you convert minutes into seconds? You will convert minutes into seconds by multiplying it by 60. So the answer will come, the time will come 900 seconds. And then speed, you know, is distance divided by time. But you have to calculate the distance. So the time will go on to the opposite side and it will become distance equal to speed multiplied by time. Speed is 2 meters per second, time is 900, and the answer will come 1800 meter. Okay. See students, we have already discussed these kinds of questions. So that's why I'm not showing you how to solve. We are just discussing the exercise. Okay. You have to complete the exercise on your own. This is just for the kind of revision. Okay. Because we have already discussed these kind of questions. The third question, fourth question, even the sixth question we have discussed. These questions we have discussed. Okay. So there's nothing different in it. Just the questions are different. Maybe question may be different, but the process is same. Okay. So shall we move ahead? Now what does the question number 7 say? The 7th number question says, show the shape of the distance time graph for the motion in the following cases. Now we just discussed the distance time graph in the previous video, and I hope you will be able to draw it. What is it saying? First is a car moving with a constant speed. So by first plotting distance and time on the axis, and then a graph that will be passing from origin. Getting it? It is a simple straight line passing through the origin. Okay. And the second one is a car parked on a side road. Second one is saying a car is parked, means it is not moving, so it is not in the motion. So this time the graph will be a straight line but parallel to the time axis. Okay. Come to the question number 13. This one. So the graph for the first part of the 7th question will be like 4th option, this. Okay, like the 4th option. Why? Because it is saying it is moving with constant speed. So you know constant speed means like this, 4th option, because it is covering equal distance in equal time interval. And for the second, it will be like the 2nd option. Why? Because it is saying it is parked. So parked means it is not moving, so there is no motion. So the distance will be constant as in the 2nd option. Now is it clear? I think 7th question is clear. Okay, so now let's move on to the 8th question. What does the 8th question say? It says, which of the following relations is correct? Formulas are given. You have to tell which one is correct. Look, speed equal to distance into time. Second is speed is equal to distance divided by time. Third is speed is equals to time divided by distance. And fourth one is speed is equals to 1 upon distance into time. Yes, it is simple. Speed is equals to distance upon time, the 2nd option. Okay, the distance covered per unit time is called speed, so the 2nd option is correct. Getting it? Now question number 9th. Again the basic unit of speed is, we have discussed, the answer will be 4th, meter per second. Shall we move on to the 10th question? Okay, see what does the 10th question say? A car moves with a speed of 40 km per hour for 15 minutes and then with a speed of 60 km per hour for the next 15 minutes. The total distance covered by the car is, what will be the total distance covered? So you can solve it in 2 parts. First, when the speed is 40 km per hour. Okay, so the time taken here is 15 minutes. So first you have to convert it into hours because speed is given in kilometer per hour. Okay, so when you will convert it into hours, it will come 15 divided by 60 equal to 0.25 hours. And then you have to put the formula of speed, that is distance divided by time, but you need to calculate the distance. So distance is equal to speed into time. Okay, so speed is 40 multiplied by 0.25, that will give you 10 kilometers. Okay, first one. And then second, the speed is 60 km per hour, the time is same, 15 minutes. So this time the time again will be 0.25 hours by dividing by 60. So distance will come out to be speed into time, distance equal to speed into time. So speed is 60 and time is 0.25. So this time the distance will become 15 km when you will solve. And it is asking the total distance, so the total distance will be d1 plus d2, means the first one and the second one, 10 plus 15, and the answer will be 25 km. Getting it? Students, 11th question you have to do it by yourself. Okay, now let's move on to the 12th question. This one also we discussed in the previous video of the distance time graph. Question is, figure 13.15 shows the distance time graph for the motion of two vehicles A and B. Which one of them is moving faster? So I told you, when a distance time graph is given for the two objects, like here it is given A and B, then if more is the slope, more is the speed, or more steeper is the graph, more is the speed. And how to tell the slope? By the angle. So which angle is more? Definitely the angle of A is more, so it is having more slope. So which one will be moving faster? A will be moving faster. Okay, we have discussed this in the previous video. If anyone had problem in this question, then you can watch the previous video. Clear, students? Now let's look at the 13th question. What does the 13th question say? Which of the following distance time graphs shows a truck moving with speed which is not constant? Please try to understand. Which is not constant. Now if I say first, no. Why? Because if this kind of graph is given, according to first, it is uniform speed. Maybe it is not starting from 0, but it is uniform speed. Okay, a straight line like this, slope is constant, so it is uniform speed. Second option shows that it is at rest, so it can't be correct. Okay, now according to the fourth option, it is again uniform speed, so the correct answer is third option, that is the curve one. I told you that there can be three kind of shapes. If you have watched the previous video, I have told you there that there can be distance time graph, there can be three kinds: when straight line, a straight line parallel to x-axis, and a curve. Okay, curve will be in the case of non-uniform speed. Okay, students, so I hope this chapter is clear to all of you. What you need to do is, you need to make the notes and solve the complete exercise. Okay, and if there is some doubt, then you can again watch the video. I have tried to explain everything, and all the questions also that are given in the exercise, the questions similar to that have been done in the videos. So try them by yourselves. Okay, but I have discussed here also. You can watch it again if you have not understood something. Okay, so in the next video we will be starting a new chapter. Okay, students, so keep studying and take care of yourselves. Thank you.